For 50 years, the fastest way to build a better chip was simple: make the transistor smaller. Huawei just announced a way to break that rule. The company says it has a path to 1.4 nanometer class transistor density by 2031, without EUV. No EUV machine, no 1.4 nanometer transistor, and no access to the lithography tools TSMC uses to reach the cutting edge. If that sounds impossible, there's an even bigger problem. The company actually manufacturing Huawei's advanced chips, SMIC, is still operating around 7 nanometers. So how can a chip made on a 7 nanometer class manufacturing process supposedly deliver 1.4 nanometer class density? The answer isn't a smaller transistor. It's something Huawei says could change the way we measure chip progress altogether. And by the end of this video, you're going to have to decide something for yourself. Is the West actually in denial about what China just did, or is skepticism here just correct? If you want to know the moment independent reviewers actually test this claim on a real phone this fall, subscribe now, because that's the update that settles everything you're about to hear. Let's start with some context, because this claim doesn't exist in a vacuum. For almost a decade, the United States has restricted China's access to the most advanced chip-making tools on Earth, specifically the extreme ultraviolet lithography machines made almost exclusively by ASML in the Netherlands. Those machines are the single choke point the entire modern chip industry runs through. No EUV, no path to the smallest, densest, fastest transistors that companies like TSMC and Samsung mass-produce today. That restriction was supposed to freeze China's most advanced chip ambitions in place. Huawei's announcement is the first serious claim that maybe it didn't. So let's start with the question everyone jumped past in the headlines. If Huawei isn't shrinking the transistor, what exactly is it changing? On May 25th of this year, He Tingbo, president of Huawei's chip division HiSilicon, took the stage at the IEE International Symposium on Circuits and Systems in Shanghai and introduced something called the Tau scaling law. Since Gordon Moore first wrote down his prediction in 1965, this industry has measured progress one way. How small can you make the transistor? Tau scaling proposes measuring something else instead: how long it takes a signal to travel through the circuit. But why should you actually care about signal travel time? Because a smaller transistor was never valuable for its own sake. It was valuable because shorter distances mean signals move faster, and faster signals mean a faster chip. That's the whole reason the entire industry has spent 50 years racing to shrink things. Not because small is inherently better, but because small used to be the only reliable way to cut that travel distance down. Huawei argues that you can chase that same speed benefit a completely different way. Not by shrinking the transistor, but by physically rearranging the circuitry around it, so signals simply have less distance to travel in the first place. Now here's the next question worth asking. Is this a real idea, or just a convenient one dressed up to sound clever? It's worth being fair here. Signal delay has always been a real factor engineers tracked alongside transistor size. Every chip designer already knows that how you lay components out on a die affects performance, not just how small those components are. What's new isn't the concept itself. It's Huawei proposing signal delay as the primary thing worth optimizing, instead of treating it as a side effect of optimizing something else. That is a genuine departure in emphasis. It is not invented out of nothing. So Huawei isn't shrinking the transistor. It's changing the geometry around it. And they gave that approach a name: LogicFolding. Here's what it actually does. Instead of laying circuits out flat across a two-dimensional surface, the way chips have been designed for decades, LogicFolding stacks them vertically, folding the layout so connected components sit physically closer together in 3 dimensions rather than spread across a flat plane. Huawei claims this delivers a 55% increase in transistor density and a 41% improvement in power efficiency, entirely through architecture, without shrinking a single transistor, and without the equipment they don't have access to. But those are Huawei's numbers. And that distinction matters more than almost anything else in this entire story. Picture a subway map redesigned so every transfer station sits one stop closer together, without moving a single track. That's roughly what's happening here. The distance a signal travels shrinks, even though nothing underneath actually got smaller. The transistors themselves are unchanged. It's the geometry around them that's been reorganized to save distance, and therefore time. Now here's where the story stops being theoretical, because this is where Huawei is taking a real risk. This isn't staying on a slide deck. Huawei confirmed the first product using LogicFolding will be the Kirin 2026 chip, debuting inside the Mate 90 series this fall. Not a concept. Not a lab demo. A real processor, in a real phone, shipping to real customers within months of the announcement. The plan extends even further, too. Huawei says it intends to fold this same architecture into its Ascend AI processors by 2030, aiming directly at the exact market segment NVIDIA lost access to under U.S. export restrictions. A real chip, a real phone, real users, and further down the road, a real attempt at competing in AI hardware, one of the most valuable and contested markets on the planet right now, which means Huawei has just handed the entire industry something valuable. A test, one that nobody at Huawei gets to control the outcome of. Markets reacted as it mattered immediately. SMIC, the Chinese foundry that actually manufactures Huawei's chips, saw its Hong Kong-listed shares jump 7.6% on the day of the announcement alone. That's not a rounding error. That's investors betting real money that this claim has substance. For a moment, this looks like it might genuinely be real. And then the earlier question comes back, louder than before. Because the company that has to manufacture this chip is still stuck at 7 nanometers, roughly where TSMC and Samsung stood back in 2018 and 2019. That's the literal manufacturing floor. A 2031 claim has to somehow get built on top of. And LogicFolding's architecture, however clever, cannot manufacture transistors. SMIC's current equipment isn't capable of producing it all. You can fold a layout as elegantly as you want. If the foundry underneath it can't physically etch the transistor to begin with, the folding doesn't matter. Paul Triolo, technology lead at DGA Group, put it plainly to CNBC. A stacked or folded design can absolutely produce real density gains on paper. That does not mean Huawei has solved the manufacturing problem sitting underneath it. So is this announcement misleading? Not entirely. And here's the honest scorecard. Fast, no lecture. What's real? Tau scaling's underlying physics. Signal propagation delay genuinely is one of the real bottlenecks limiting chip performance today. And multiple Western labs, including IBM's own nanostack research, are exploring similar territory through different specific methods of their own. This isn't a fringe idea born out of desperation. It's a direction the whole industry is drifting toward, as pure geometric shrinking runs into physical limits that are getting harder and harder to push past with brute force. What's unproven? The 1.4 nm equivalent comparison itself. Huawei released no independently verified data alongside the announcement. No third-party lab has confirmed the 55% or 41% figures, Several analysts, including Big Go's financial coverage, describe logic folding as a possible variant of existing hybrid bonding techniques already used elsewhere in the industry, and describe the 1.4 nanometers comparison as an equivalent performance framing rather than a literal physical claim about transistor size. What's the biggest problem? SMIC stuck 3 full node generations behind, with no confirmed lithography path past 7 nanometers and no public roadmap that convincingly closes that gap by 2031. What's the wild card? Whether any of this survives contact with a real phone in real hands, running real benchmarks nobody at Huawei controls. A real technique, wrapped in a comparison built to sound bigger than what's actually been independently confirmed. Both of those things can be true about the same announcement. But let's actually sit inside the other possibility for a second. Let's assume Huawei is right. Not completely right. Just right enough. If logic folding delivers even a fraction of its claimed gains inside a shipping phone, this stops being a geopolitical talking point. It becomes a real, measurable battery life and performance difference sitting in millions of actual devices, independent of whatever the 1.4 nanometer marketing comparison ultimately turns out to mean. And it changes the underlying question the entire industry is asking. Not, can China build a true 1.4 nanometer chip? But, does China even need to build 1.4 nm the way everyone else does, if it can get equivalent results a completely different way? That's a genuinely bigger idea than one chip announcement. It would mean the export control strategy the West has leaned on for years has a real architectural blind spot in it. But there's one problem Huawei can't fold away. Manufacturing. Lithography. SMIC's ceiling. Architecture can rearrange what's already possible on a given manufacturing process. It cannot manufacture what the foundry physically can't produce yet. Those are two completely different problems, and logic folding only solves one of them. And that brings us to the strangest detail in this entire story. The one that says more about Huawei's own confidence than any density percentage they've published. Huawei's own chairman has publicly thanked the United States for its export restrictions, saying they supercharged China's domestic semiconductor industry rather than crippling it. Separately, reports indicate Huawei may have invested directly in SiCarrier, a Chinese equipment maker building homegrown alternatives to ASML's EUV tools, a company that recently sought $2.8 billion in financing to keep pushing that effort forward. So Huawei isn't just betting on logic folding. It's simultaneously funding a completely separate, expensive attempt to solve the actual lithography problem underneath everything, which raises an uncomfortable question. If architecture alone were genuinely sufficient to reach the industry frontier, why is Huawei still spending billions trying to solve lithography directly? Why fund both? Don't just find a way around the wall. Also keep funding a team trying to knock it down. That dual bet is the most honest signal in this entire announcement. More honest than the 1.4 nanometer number itself. Even the company making this claim doesn't appear fully certain architecture alone gets it all the way there. Now let's actually deal with the title of this video, because it's a real question and it deserves a real answer, not a slogan. Is the West actually in denial here? Real denial would mean dismissing the underlying physics entirely, and the physics genuinely isn't in dispute. Time-based scaling is a serious research direction multiple non-Chinese labs are chasing too, using their own methods. But treating an unverified density comparison, with no independently confirmed data, built on top of a foundry still stuck 3 full node generations behind, as equivalent to an actual manufacturing breakthrough isn't denial either. That's just applying the same evidence standard you'd demand from any other unverified industry claim, from any country, made by any company. Ask yourself honestly whether you'd extend the same benefit of the doubt to an identical unverified density claim from a company in Texas or Taiwan. If your answer changes purely based on which country made the announcement, that's the actual bias worth examining in either direction. And it's also fair to say Western chip makers make exactly this kind of forward-looking, unverified claim regularly, years ahead of any shipping product, and rarely draw the same instant scrutiny Huawei's announcement triggered within days. That doesn't make Huawei's numbers accurate. It does mean part of the skepticism aimed at this specific announcement is genuinely about the source, and not only about the substance. So the honest answer is neither headline. It's not the West refusing to see something real, and it's not Huawei fooling everyone with clever marketing. It's an industry watching two different things happen at the same time. A legitimate new engineering direction on one hand, and a marketing claim riding on top of it that is currently running well ahead of any independently verifiable proof on the other. There's a useful historical parallel here too, one that cuts against pure skepticism and is worth remembering before writing this whole approach off. AMD spent years trailing Intel on raw transistor scaling, watching Intel hit node after node first. Instead of matching Intel node for node, AMD leaned hard into chiplet architecture, splitting processors into smaller interconnected pieces, rather than manufacturing one giant slab of silicon. That architectural bet eventually let AMD compete directly with, and in some workloads beat, a company that held a genuine manufacturing advantage over it for years. Architecture-first strategies have worked before, against real odds, in this exact industry, within recent memory. That history doesn't prove Huawei's specific numbers hold up. It does mean dismissing the entire approach as inherently hopeless ignores precedent that's still fairly recent, and still very relevant. So we're not going to know the real answer yet. Not from a conference stage, and not from a press release. No matter how confident the language on either side sounds. Forget the presentation. Forget the political headlines. Forget the 1.4 nanometer label for a second. The real test is sitting inside a phone. The Mate 90 this fall. Independent reviewers, not Huawei's own slides, not a company-controlled benchmark. Measure the battery. Measure the performance. Measure the efficiency under real, everyday conditions. And then we'll actually know whether Huawei changed the game or just changed the wording used to describe it. Watch three things pass today, because this story isn't over until we see whether Kirin 2026's real-world benchmarks come anywhere close to Huawei's claimed density and efficiency numbers once independent reviewers get their hands on it this fall. Whether SMIC's roadmap actually moves past 7 nanometers in any verifiable way, since LogicFolding's long-term promise depends entirely on a foundry that hasn't yet proven it can go much further without the lithography tools everyone agrees it's missing. And whether Western chip makers start quietly discussing similar folding or stacking architectures of their own, because if IBM, Intel, or TSMC start moving toward this same idea publicly, that tells you the industry believes the underlying physics a lot more than it believes Huawei's specific 2031 date. So before you go, tell me where you land. Genius, if you think tau scaling and logic folding represent a real, credible new direction for this entire industry. Gimmick, if you think this is a political announcement running years ahead of any actual proof. Drop the word in the comments and tell me why, because I read every one. And the best answers usually change my mind more than they confirm it. The verdict on Huawei isn't ready yet. The Mate 90 is. And when it lands this fall, that's when we'll actually know which headline was right all along.